The short video you are watching now is actually stored in the service provider's data center. More specifically, it is stored on a solid-state drive in the data center. The solid-state drive is located inside a server. When we watch videos, the server can respond to our request and send out the short video. There's a question: how exactly is the video transmitted to our phones or computers? There's a simple way to solve this problem, that is by using satellites. Video data is sent to satellites from the data center, then the satellites relay the data to our phones. But there's a big problem with this method. The distance from the satellite to the equator is 35,000 kilometers. The round-trip data transmission exceeds 70,000 kilometers. This causes a significant data delay. If using satellites is not feasible, then how else can it be solved? The answer is to use optical fibers. These fiber optic networks spread across the globe via land and sea, enabling global connectivity. Your phone can connect to the internet via cellular data or a Wi-Fi router, but ultimately it's connected to the fiber optic cable network. The fiber optic cable consists of thousands of fiber strands. Each strand is as thin as a human hair. Fiber optics use light to transmit information. This determines the high speed of fiber optic transmission. Let's look at an experiment now. This is a triangular prism. When light passes through the prism, refraction of light occurs. Now, by doping, we can instantly increase the refractive index of the glass. As more doping is added, the light continuously approaches the surface of the prism. When all impurities are shot in, the light suddenly returns inside the prism in a pure reflection form. This phenomenon is called total internal reflection, and fiber optics transmit light signals based on total internal reflection. The inside of the fiber optic is a high refractive index cylindrical glass, surrounded by a low refractive index glass. When light enters at an angle greater than the critical angle, total internal reflection occurs. Finally, a protective layer is added on the outside. This way, light can be transmitted over long distances, but this distance is not infinite. After more than 100 kilometers, due to various losses, the light signal attenuates. So, after a certain distance, the light signal needs to be amplified, and then continue the light signal transmission. The question is, how do these light signals find our phones or computers in the vast crowd? This brings us to an important concept, that is the IP address. Whether it's a server, computer, or phone, they all have an IP address as a unique identifier. An IP address is like your home address. With this address, any information can be accurately mailed home. You can easily view your device's IP address on your computer or phone. Also, the server we use to browse short videos has an IP address. With this IP address, you can access any information you have permission to access. But since IP addresses are hard to remember, another thing is needed, that is the domain name. Domain names are easy to remember and correspond to IP addresses, so we use domain names when accessing websites. The question is how to find the corresponding server IP with the domain name. This requires another new thing, that is DNS. DNS is like our phone book. You can find the corresponding IP with the domain name. Internet service providers manage this DNS server. When a phone or computer accesses a domain name, the short video app or browser sends a request to the DNS server. After obtaining the corresponding IP address, the browser or app forwards the request to the server at the data center. Once the server receives the data request, it converts the video you scrolled through into zeros and ones of binary data. This binary data is then divided into different data packets. Each packet includes a sequence number, server and phone IP addresses, and other information. Then these video data are transmitted via fiber optics. Each data packet can independently choose the best available route. If you are connecting via cellular network on your phone, then the data packets are first sent to the signal tower. Then the tower transmits them to your phone in the form of electromagnetic waves. Finally, a complete short video is displayed on your phone. If your phone or computer is connected via Wi-Fi, then the data is transmitted directly to your home router via fiber optics. The router converts these light signals into electrical signals. Once your phone or computer is connected to Wi-Fi, you can happily scroll through short videos.